Okay, so hi everyone. First of all, just to see if voice is fine, can you all hear us? Okay, so hi everyone. First of all, just to see if voice is fine, can and Atul and Abhay, can you also guys just try speaking and see if this
Hello.
is okay?
Hello, hi
Please.
there. Okay, so
Okay,
I think
cool.
there's a delay, but it's working.
Mm,
Awesome. Oh wait, Ranjit, can you like scroll up maybe like if to see the hello? Like I don't know where things are. Oh wait, does it say online math club whenever I write?
Yes.
Oh, okay. Never mind. Too late to use another account. Um, so we should start, right? Oh wait, okay. Yeah, let's
Oh, one
start.
second. The Miro does not seem to be working on YouTube somehow.
It's not.
No.
Okay.
Okay, should be working now.
Awesome. Wait, let's try writing something. Uh, okay. I just put this huge oval. Let's see when it. Okay, awesome. We'll start then.
Okay, yeah, let's start. So today basically me, Abhay and Atul will try attempting some problems from the EGMO 2022 which just got over and let's see how it goes.
Are we allowed to see problem now?
Yeah, I guess let's see problem one. Problem one should already be visible on YouTube actually.
What is problem 3?
Oh,
Okay.
oh wait, are we using the PDF or
I use the PDF to show.
awesome?
No, no, what is P3?
Okay,
A1 plus A minus 1.
let's start with
So
P1 first though.
Yeah, yeah.
there's no
Motivation.
combo. Okay, no. Okay. Um.
2 NT problems. EGMO is scam.
Yeah.
Okay, I we were literally doing this configuration well. Oh, Q lies on AC such that BQ is equal to
Wait, C
BC.
centered.
No,
Oh, okay. BC less than AB confused me.
BC less than AB and
Oh, I
BC
just
less
want
than
BC
CA.
similar. Okay.
And P lies on AB such that CP is equal to BC. Whoops.
Oh, this is that Brazil. That's similar.
Uh,
Okay.
BQ is
Also, can you both see my diagram? Like at
yeah.
least what I've done so far. Okay, cool. T is the circle.
I mean, I'm not sure what you've done so far, but I am seeing something
A triangle basically.
with P and Q. Yeah.
Very accurate too. Like BP looks like BC.
BQ is supposed to look like BC. BQ is BC CP.
Mm. Let T be the intersection of the circumcircle of triangle
You are being asked to
ABC.
reduce pen width.
Done.
Uh,
Okay.
Prove that S the intersection of the lines.
Okay, apparently these 3 points are collinear.
This looks oddly familiar for some reason.
Okay.
Uh,
Wait, if I is in center of triangle, then I is perpendicular to BC or something. Because this is a Brazil problem.
Okay.
I think, like, I
Are
don't know.
you sure? Okay.
No,
Interesting.
it's probably not.
Also, we don't know any angles, right? Which is sad.
Huh?
we
Right.
can get, I mean, we can get the isosceles triangle stuff out of BQC and CPB.
Right. Okay, so I'll just write that this angle will be minus C.
Oh,
Hmm.
oh, I misread problem. Interesting.
Um,
Then PNC are nice, no? Reflection across vertices across feet of altitudes.
Yeah.
which ones?
P
I'll
and Q, you reflect B and C across feet of altitudes
I'll
from B.
let feet of altitudes be Q prime as B prime.
Hmm. Oh,
So concept of APQ is honestly strange.
Angles are probably
Oh,
nice.
are APQS just concyclic?
Oh,
APQS.
APQS.
I think.
That would wait. No, what is is that possible? No, that would mean 180 minus B plus 180 minus C is 180.
Wait, really? Okay, okay.
I mean, B and C, B that would force B plus C is 180, and that's not
Right.
true.
Wait, so instead PTQS is concyclic, right? No,
Uh,
I'm just being very silly. Yeah, no.
could it be?
Wait, let's just do this.
Could maybe?
It's,
Okay.
90 minus C by 2.
yeah, it is concyclic. Just
Right.
2A and this is A plus B plus C minus A.
Yeah, sorry. And this is not 90 minus C by 2, it's 180 minus 2C.
Hmm.
Okay, so this is concyclic, which is nice.
Hmm.
Like angle PST is angle PQT.
Which is 90 minus A.
Yeah.
So you just want HS. You just want SH as angle bisector, right?
HS is angle bisector of.
BSC.
Is it?
It has to be 90 minus A, each of those angles, if they're clean.
Yes, yes, that's true.
Right.
Actually, because just fact 5.
It is.
Yeah, like okay, so we got PQ
Ah, okay.
ST concyclic, and since TP is equal to TQ, that angle bisector is the case. So we just want the other angle bisector to meet at H.
Hmm.
Oh, H is just the incenter of BSC though.
Oh, right. Okay, well done.
Okay, so I'll just outline the
That
proof for
Okay, that
everyone.
was nice.
It's very slick, yeah.
Yeah.
So
this is a
H,
nice plot.
oops, two things. So H lies on bisector of
Nice.
CBS and BCS implies H is right.
Also, like, this is not fact 5 as we have discussed.
Oh, midpoint arc lemma.
Yeah, something like that. It's called. P2. Wait, can we just look at all 6 problems and decide what looks nicest?
Sure, or we can just go in order, I thought. Since
Or
I don't,
P1, then P4, then P2, 5.
I was thinking 1, 2, 3, 4, 5, 6 would either work.
Let's do 4.
Okay, cool.
D2. Yes.
I'll just pull 4 up.
Given a positive integer, determine the largest integer
How
n
is
for
PDF
which.
open for you? It refuses.
Oh, by pull up, I mean just like put it on this
Yeah, no,
screen.
it's not opening for me.
Oh, yeah.
D2.
This looks kind of weird.
Where is it? What is this? Okay,
Yeah, like,
sign. Not opening.
if you're on YouTube, you can also.
Oh, it loaded.
Oh, okay, cool.
What is what is P6?
Okay, when we get there, we'll see.
The geometry.
No, there are. What are these points? Suppose 5 points are concyclic. Prove that 5 other points are concyclic.
For P4, I want to let bi equals ai minus 1 plus ai. Just because
Makes.
everything is more easy in terms of
Wait,
bi.
which one?
How are you writing AK plus
P4.
1? Oh, of course. Okay, you can write as difference.
So b1 is minus 1 by n and bk plus um
I just put the problem on the Miro board for. Okay, it's fine. Never mind. I'll just look.
okay, bk
BK.
into bk plus 1
Hmm.
is equal to bk plus 1 minus bk.
Hmm.
Okay, this is very much nicer. Oh, also
Um,
from any bi can we recreate the ai somehow?
Yeah. Uh,
Just let a not be random, a1 to work, a2 to work, a3 to work.
yeah.
Okay,
So this is equivalent to BI being any random GLs.
right. And we have to see when this is possible.
Magic Alchemy if I predict.
for which one rate? Okay.
Like BK plus 1, like take BK to other side and we have like take product of all equations. Oh, it's not cyclic. All things won't cancel.
Hmm? Yeah.
It's not
We can
cyclic.
we can write bk plus one in terms of bk. What do we get? Bk plus one is
Right.
equal to minus bk by
Minus bk by bk plus 1.
bk minus one.
Minus 1.
What? Yeah, thanks.
So you just don't want BI to be 1.
Yeah.
Ah, okay. Is that all?
If you don't want it to be 1, you don't want previous term to be half.
Also, I mistyped, not mistyped, I think I miswrote this. The problem is AK minus 1 minus AK plus 1, which
Hmm.
is
BK.
BK minus BK plus 1.
Ah,
So you don't want it to be -1.
Uh, so, right, I'll just write that again. BK plus 1
Also,
is
okay,
equal
like
to
both of them are equivalent by negating bi.
uh, BK by 1 plus BK? Yes.
Hmm.
Okay, so let's just see how the sequence goes, I guess. Minus 1 by n to
-1 by n minus 1. Really?
uh,
And when it hits 0, you're done?
wait, then isn't it just not happening for any n or something?
Oh, the capital N is fixed. You want to maximize it.
Oh, okay, okay.
wait, am I misreading this? Oh, okay, never
It's
mind.
asking how long you
Small
can
n
take
is fixed
this.
and large n you want to just stretch out.
Hmm. Maybe we can try it for small n equals 2 and see what we get.
Like this, I think is just working actually.
Yeah.
Like if by induction we'll get that b1 is minus 1 by n, and by induction we'll get that bi is equal to minus 1 by n plus 1 minus I.
Hmm.
Right.
And
And
this means it's not possible if I equal to n plus 1. So up till b n you can go. So capital N equal to small n unless I'm messing up.
Yeah, I think so.
that's it.
Yeah, because given some BIs we discussed how we can recreate the AIs.
Okay.
Like just set A not to be random.
No, that's all.
A1, yeah, this should work.
Yeah, I think
This
it
feels short. Okay, it might be.
Okay,
would.
let's just check this part was correct. Minus 1 by n by 1 minus 1 by n. So comes n minus 1. Yeah, this you get. In fact, okay, to make the proof nicer, it probably makes sense to define 1 by bi if it
Hmm.
exists. And I'm
Okay.
predicting you'll just get some like super nice equation out of this.
Right.
Oh, wonderful. BK plus 1 is a BK plus 1. Or, yeah. And you start with -n.
Yeah.
Okay.
Though that's more hand wavy because you have to show things are not zero. So I like this proof more. As in, it's not hand wavy. You have to show it's not zero.
Yeah.
Okay.
Okay, P2 or 5 next.
Your call.
P5, P5. It looks there's styling involved.
Okay.
Let's do P5.
Yes, it's combo surf I wants to do.
Yeah.
Okay.
For all positive integers n comma k, let f
Oh,
n
if someone
comma
is
k.
at the door, I'll be back.
Yeah, sure.
Okay, so let's do P5 now.
Yeah, just pulling it up.
I just realized I haven't made a single mark on the board right now, so I'm just gonna write p5 like that for no reason at all. Um, for all positive integers n comma k, let f n comma
Okay,
2k be the
and
number of. Hmm?
nothing.
Hello.
Okay. It's
Okay,
just like try
So you're
stuff.
only looking at only symmetric tilings, otherwise reflect across. Like it's
yes,
too
that
close.
makes sense.
Hmm.
Wait, does n get reduced to n minus 1 by 2?
Does it?
Like take the middle row.
Hmm.
Oh, n can be even or odd first of all.
Yeah.
Wait, and can be even? Like, can't we just like reflect any tiling across? Am I
Well,
saying
at
And you
something
can
least
get
yeah.
the same tiling. Okay,
stupid?
hi.
Okay.
Do you want to take n odd and even separately?
How does it like uh differ? As in
I don't know, but I feel like when we try to reflect stuff, it will be different based on whether n is odd or even.
also can you not do something like if there's a two by two square which is covered by dominoes, like as in just take
Huh.
the other one also.
If you want
Like
to
there are many
match
ways
like
to
that,
do it.
that's annoying, right? Like, suppose
Yeah.
it looked like this. Um, Sorry.
so I'll be back in 1 second.
Yeah, sure.
Yeah, sure.
If it looked like this, you're kind of, I guess, matching this to this. But this is
Yeah.
also getting matched to something like this.
Yeah, that's messy.
So I like your symmetric idea much more.
Okay.
I think for n odd, it does just get reduced to n minus 1 by 2.
How?
Like, okay, suppose n is odd. Let's take the drawn thing. Consider flipping it across the n.
Flipping it across the
Um, like there are n
oh,
rows.
yeah.
So flip across the middle col
Where K is there,
middle
like
row.
K
Flip across the
thing.
middle row. So if this was a domino, it will go to this being a domino.
Hmm.
And we only need to look at symmetric things. So we only need to look at when this is the case. Does that make sense?
Yeah, okay, it does get reduced and minus 1 by 2.
Yeah. And it's odd for n minus 1 by 2 only if it's
Yes.
odd.
Yeah, yeah.
So we only look at even.
Yeah. I mean, odd might get reduced to an even thing. Like you start with 5, you're basically solving it for 2.
Hmm.
Hmm.
But like if we solve it for evens, then we can regenerate whatever solution.
Yes.
Yeah. Uh,
Okay, I drew n equal to 4.
okay.
Can we now think of tilting the board by 180 degrees? Like the same matching thing idea.
Okay. So first we're only looking at symmetrical things, right?
Yeah, and in symmetric things, I'm suggesting, okay, let's just put all symmetries on it, like symmetry this way, and
Also,
rotationally.
can't you biject the symmetric cases to deleting the middle two rows?
Wait, seriously, how? Oh, okay, that sounds better.
Wait, what?
So just do the same symmetry, flip along this axis. So you either have a domino like, no, you can't. There might be a tiling like this, which is symmetric.
Yeah, that's the point. Like they come together, right?
These two.
No, I mean, or delete this. So now, inside.
Oh, okay.
Yeah, that was the idea. Like
Yeah,
delete
that's
this. Now
pretty
put
cool.
these two together.
Okay, I'll also just draw it in case someone doesn't see it for a more realistic. Like if you have
I
two.
might be stupid, but like, how many possible symmetries are there for a 4 into 4 board? Like, for some reason, I'm trying to remember some weird group theory things. Like, we can like, I mean, like, how many possible ways are there to? Am I saying
Right,
something
four by
stupid?
four.
Yeah. Like, I mean, we can like flip it across the x-axis and the y-axis.
I see.
Um, okay, like for example, let's say we're rotating by 9. No, that's never mind. I'm just saying something randomly stupid. Don't worry about me. Okay.
So this happens. Mm, this still feels very suspicious. Like I'm not sure
The
why.
deleted thing you can do in some ways. I think.
Right. Wait, so are we claiming that um fn comma 2k is equal to fn minus 2 comma 2k mod 2? Sorry, n minus 2 comma.
Yeah, I was hoping.
Mm,
So that's going f0 comma k equal to 1, I guess, just vacuously.
Hmm.
So that's claiming like f2 comma 2k is odd always, which is
that's
false.
Ah, yeah.
Yeah, I think the issue is that multiple things might go to the same one
Yeah, makes sense.
mm,
when you're squishing it, which was not an issue for the odd one because over here you literally have the formula that
Yeah.
it's symmetric plus. Yeah, okay.
Yeah, we can assume it's symmetric both ways, right? Vertically and horizontally.
Yeah, first make it symmetric, only consider the symmetric vertically, then only
And
consider the symmetric horizontally. Yes. I was also curious what happens if you make it symmetric about a 180-degree rotation.
isn't that just vertical
Oh, no, no,
symmetry?
no.
Symmetry of that.
Yeah, it is.
no. Wait, what?
Actually, your 2 by 2 square will somehow save us, I feel.
Oh,
Wait, isn't like a 180-degree rotation and a vertical thing different?
oh,
I
Yeah,
mean,
but if you
vertical
flip
just
it horizontally and vertically 180-degree, it will also be.
never mind. Okay,
Yeah, okay. This was your.
yeah.
Okay, so let this be a tiling which is symmetric horizontally and vertically and take the middle 2 by 2 square.
okay.
I'm claiming it can't stick out. Is that true? Oh, it can.
It can, like, just put here.
Ah,
I want to like divide along both midlines and hope for the best.
hmm.
Hmm. Should we try like smaller cases and see if it's actually
Oh yeah,
see
let's.
what it's
I
got?
guess we should try n equal to 2 at least.
Hmm.
N equal to 2 is saying there exists an
Fibonacci.
even Fibonacci.
Yeah.
Hmm.
Wait, I'll just look at the question.
Even Fibonacci with even index or something. But like it's probably either one one.
Even Fibonacci with
Uh,
8. 8.
Hmm?
Like the sixth Fibonacci number is 8.
Yeah, okay. I was writing it motto. It just
Okay,
repeats 110.
right.
Okay, so like there are two exact solutions for two.
Okay. So we got that f2 comma 6 is even. Will it be correct to claim f2k comma 6 is even?
Is it?
Just a guess.
Oh, let's try 4 and 6.
Mm, wait, actually, sorry, isn't f2 comma 2 even? Do we need to try?
it's
Ah,
even, yeah.
okay, yes.
Oh, and f2k comma 6 actually is probably odd. Wait, f2
Oh,
comma 2.
what order is it start?
It's not
It
fn, I
started,
think. It's f.
started with.
It's f2k plus 1 instead of.
Oh, I see. Yeah.
Uh,
Oh, sorry. I will remove the.
so f3 comma 2 has to reduce to what? It reduces to f 2 comma 2, right?
f2 comma what?
F3 comma 2 reduces to f2 comma 2, right? I mean,
I think f3 comma 2 reduces to f1 comma 2.
wait, what? It was n minus 1 by 2, right?
Yeah, so 3 minus 1 by
Oh,
2.
never mind, right. Okay, and f1 comma 2 is just that, okay.
F f1 comma anything is odd. So f2 power x minus 1. Yeah. So like 2 power x minus 1 satisfies the problem criteria.
Right.
Yeah.
I'll just close my window in a second and be back.
Was it supposed to be out for all K? Oh,
I have a weird, yeah, it's odd for all. I have a weird feeling that like these are the only
that would
things.
make sense.
Okay. Can we like, no, do that. No, we can't do that.
What were you trying to do?
Something extremely stupid.
More
Um,
details?
no, okay, that was an extremely stupid idea in hindsight.
Have you figured out any number cases at f4, 2k is even?
Do we know if f4 comma what about f4 comma 2? What is?
f4, 2 is odd. It should be, I think, fifth
Oh,
Fibonacci.
yeah, it's all.
So 5. f4, 4 though. Um,
Is there anything we can say about fn comma n?
okay,
Because it might
interesting.
have more symmetries. I don't know. Across the diagonal, maybe because.
Ah,
Oh,
yeah, let's make it symmetric across the diagonal also.
what is a diagonal?
Like, just a
No, as
sec.
in the if it, and it's not n comma n, what is a diagonal?
No, make it n, since you're stuck with even.
How do you assume any like n comma n?
So we'll show that f of n, n is even, I guess.
Okay.
And that will
Or we look
finish.
only at that case for now. I
Yeah.
don't know.
Yeah, let's just try to see what diagonal gives for f n, n.
Um,
Isn't diagonal the same as rotating 180 degrees though? No,
is
it's
it?
not. It's not. Wait, in fact, nothing is symmetric across diagonal, right?
Hmm.
Correct.
Nothing is symmetric across the diagonal.
Yeah,
Oh, yes.
nothing can. Yeah, whatever cell
It is
of
always
yeah.
Okay, cool.
But I feel like n comma n has to have some additional symmetry. That might not be true though.
I mean, this just finishes though.
yeah, just give even, no?
Hmm?
Like for each
The
tiling of
effect is
n,
not
n,
diagonal.
look at the reflection of the tiling across the diagonal. The different tilings, and you're pairing them up. So the total number of tilings is
Right.
even.
Okay.
Okay, I guess this proof also quickly summarized.
What? Oh, the for that.
So say we have stuff like f9 comma 4 is even
Hmm.
9 comma 4. Yeah, 9 comma. I mean, we have a like now we have like a whole bunch of.
Yeah. And they should do for all, like all numbers. Like you start with an odd number and keep on subtracting 1 and dividing by 2. And you
Hmm.
have to reach 1 for the problem to be true. And that should
Yeah.
just imply that the number you started with is 1 less than the power of 2.
Wait, we're done.
Yeah, I think so.
Wait, how do you deal with
We're
even?
done. What?
Wait, even we just did, right? F for an
What?
even f 2k, 2k is even.
Oh, for any k? For any k?
Yeah.
Okay, wait, no, but like,
No.
what
Okay,
about? Wait, what about fn comma? I mean, like some even comma something else. Like
Like the
2n
problem
comma
is
2k.
the problem is just saying that find all n such that the number of base for any k is odd.
Oh,
So for n even there is some k,
oh,
which is this number
oh,
by 2.
sad.
oh, okay, never
It's
mind. Okay,
nice
wait.
only.
Okay, yeah. This is apparently Anka.
Makes sense. His are always nice.
Yeah.
Whose problem is this?
Ankan.
Ankan.
Oh, oh, we only need to find. Okay, find all possible. Okay, yay.
Yes, P2.
Yeah.
Like we are doing P6 last, whatever happens. Like
Yes, yes.
look at the statement. What is this?
F0 comma K is equal to 1
Okay, P2 now then.
or right. I guess we don't need to like show the exact details of I2 par x minus 1 works. It's
Yeah, but
pretty
the recursive thing,
clear.
it's
Yeah.
equivalent.
This is a nice problem.
Yeah,
Okay. Wait, P2, right? Just give me a
yeah.
second.
P2 and P3 both are not compy, right?
No, only combi is P5 for you.
This is bad. I mean, this is such a bad case.
Like
There's only
P2
one
and 3 both
compy.
look like NT.
This is so bad.
I love your criteria for judging if a paper is bad. Not enough
There should be
combi.
at least 30% of the paper has to be combi.
Like I wouldn't mind 50%, but
I wouldn't mind 100%.
yes, we need a combo Olympiad.
We do. This might
Yeah,
be
that's actually.
controversial, but I
Hmm.
consider combo the most Olympiadish of all the
Isn't
that.
Geo the most Olympiadish technically?
No, there's too much structure in stuff. Like there's no structure in combi. That's the good thing. It's like just like if you know what I mean. Like every question introduces its own structure. Um,
I guess.
I don't know.
Okay, P2. F of A, F of P, and F of A plus B at least two are equal. You just want to set F1 primes.
Hmm?
Uh,
We just want to set F1 primes, it's multiplicative.
yeah, yeah.
Hmm.
And F of 1 1.
What would you guess a solution would be? Something like f of p is equal to q and f of pi is equal to 1.
Oh, just make 1 prime constant value and everything else 1.
Yeah.
And it works because I see VP of A plus B is
Yeah, VP
minimum.
of two of those is equal at least.
Yeah.
Does f of odd equals something like 0 and f of even equals 1 work?
I think don't think 0 is
0
allowed.
into N.
Oh, no, mind.
They specified because some people will wrongly believe 0 is there in it. Okay, I
Hmm.
should actually not say that. Rhythm assumed that today.
Oh, okay. Okay, this is the solution. Hmm. Okay, let's suppose two different primes are not 0. F of oh, q needn't be a prime. So to make it misleading, I'll put k.
Ah,
F of p1 is equal to k1. F of p2 is equal to k2.
hmm. You can generate infinitely many bad primes this way. Because
Right,
you have like say P1 plus P2 par alpha is equal to um, one of them.
right.
And so like it's non-zero.
Hmm.
Same prime can be the cause for the non-zero. No, I guess. Okay, let's call a prime bad. p not equal to 1, p1, we are starting out with this. Does 2 and 3 both being bad give a contradiction?
Hmm?
They have to be equal to the same thing.
Okay, f of 2 is equal to f of.
But like that's just coincidence because like
No,
3 is
no,
plus
wait,
3.
this will give something. F of 8, and f of 8 has to be equal to f of 9 in this case.
Wait, why?
If 2 and 3 are bad, I just took that as an
Exactly.
Ah,
example.
Okay, so in general you can do the following, right? Consider number p2 per uh, k times p minus 1 minus 1.
Right.
Or okay, this way maybe minus p2. It is
Ah, it's either equal to f of p2 or f of p to the power that huge thing.
hmm.
yeah.
Wait, is that the point you were trying to make? Or
No, that okay. I wrote it wrong. I mean just this p2 to the power p minus p1 minus 1 1 this and p2 to the power p1 minus 1 minus wait, Miro just hung. But like that minus 1.
Wait, random question. Is it possible to have like infinitely many values for f? I mean, I don't know.
It has to be.
it that is our solution set.
What?
Like we had
Setting
that
1.
solution, right? Set one prime to be anything
Hmm?
and set the other primes to be one.
Yeah, so okay, we're getting k square and so on. Okay.
Yeah.
Yes, this is the solution.
Um,
Okay, this is true. And I want to show that a smaller prime is bad somehow because 2 and 3 bad is finishing.
Ah, oh, that sounds
um,
interesting. Also, this itself seems sus like this taking p2 to the power p1 minus 1 because both f of p2 to the power p1 minus 1 and f of that thing minus 1 is greater than 1 because 1 is divisible by p2 other by p1.
Yeah.
hmm.
Oh, f of p1 equals f of p2.
Hmm?
F of p1 equals f of p2.
What?
Why?
If they're the smallest, if smallest bad primes. Otherwise, just consider p1, p1 minus p2.
Hmm.
Sorry, suppose p1 less than p2, take p1 and p2 minus p1. So, like between f of p1, f of
Oh,
p2, and
I see.
f of their mod, which is equal to 1.
Hmm.
Two are the same. So, if they're the smallest bad primes, f of p1 is equal to f of p2.
Hmm. That's pretty cool. And also we have that rad of everything is the same
Rad of everything?
because from this thing
Wait, what's that?
a set of prime factors of something
Okay.
like square
Wait.
factor of a number, like essentially because here we must have f of p2 to the power p1 minus 1 equal to f of p2 to the power p1 minus 1 minus 1.
I think we can just be a lot more generic. We can say that f of anything is f of p1 to the power something.
Oh, can we do that?
Yeah, that's a bit more generic than the rad statement.
That will probably finish. No, like there's
I
no way that works.
Yeah, I mean we should have enough to finish honestly. F
Hmm.
of p1 equals f of p2 is huge. Oh, actually, I think you're right. Like, just f of p1 square minus p2 take. No, never mind. Uh, of p2 to the power p1 minus.
Is it possible to have like infinitely many bad primes?
We must have infinitely many bad primes.
Right, never
Right.
mind. Okay.
Like if
Hmm.
there are at least two bad primes, then there are infinitely
Infinitely
many.
many.
Infinitely many, got it, yeah.
F of p1 is, I'm just letting this value be c.
Hmm.
Then f of p1, f of p2 to the power p1 minus 1 is equal to c to the power p1 minus 1
Hmm.
is equal to. This is messy though, honestly.
Yeah,
You have to make a smaller prime, but somehow.
yeah,
Uh,
so
What if,
next, so this prime dividing this value will have a value smaller than c. Otherwise,
why?
simply not enough.
Its
Like
value
because
will be
bigger
larger then.
p2, no, like this is equal to exactly c per p1 minus 2.
Yeah,
Like suppose it's a prime p3 bigger than both p1 and p2,
yeah.
then just,
F of p3 might equal c to the power p1 minus 2, for instance.
oh, there can be
uh,
lots of ones.
Mm.
People claim p2 was the best, we will see.
Oh, okay, that's cool. I think combo or any Olympiad subject does not say the same. Like I just checked chat.
Say the same?
hmm?
No, like Sunanda was like combo more or less stays the same after high school.
Ah,
Oh,
From what I've heard, it's just completely different.
I mean, like, we don't study Euclidean geometry. Like, people don't research Euclidean geometry the same way, I think. And combo might
Right.
have some similarities, but it is very different. Because the stuff that we can do in Olympiad geometry, it's already been done a long time ago. I mean,
Yes. Right.
yeah. Graph theory is suspiciously similar, though. Some of the things that, some of the arguments and things like that. I don't know enough math to talk about, so I don't take my word.
Also, what happens if we just consider f of p2 square minus t into p1? I think this should work.
oh, you want p1 square minus tp2?
It doesn't matter.
Hmm.
No, no. I'm taking p1 less than p2.
Yeah,
p2 square minus.
then t might become big, right?
Yeah, t. Okay. Let's take p1 square.
What if p1 square is less than p2?
Then I think we're just done with p2 minus p1 square.
Ah, okay.
Okay.
So f of p1 square minus p2
Minus tp2.
minus tp2. It's less than p2. Sorry. So okay, so you can take p1 square minus tp2 to be less than p2.
Greater than 0.
Yeah, but f of this p2 is not equal to 1. since
Which C square.
f of t p2 is equal to c.
Yeah. Oh, nice.
Like t is too small,
Right. Okay.
which implies p2 is not the second biggest
Yes.
even prime.
Okay, nice.
Nice. Yeah, that's
Okay, and this made me realize that we had for 2 and 3 there was no need to go to 8 and 9. We can do the same thing. F of 4 equal to f of 3, and that's like a much quicker.
Yeah.
hmm.
Okay, again I guess I'll quickly outline the proof. So take p1. This is very short actually. This is cute. Like once you actually get the idea.
Yeah, I was ready to do like random stuff. Like you can generate arbitrarily long chain of equal things and
Hmm.
instead just look at two smallest.
This is a nice question,
Wait,
but it's
that was
very
four and a half hours or 4 hours?
straightforward.
Someone was saying 4 hours.
Hmm?
I thought it was 4.5.
Is it 4.5 or?
Yeah, 4.5.
Yeah.
Okay, P3 next because we will refuse to do P6 on principle.
Right. One. I just
Krishna
also
the
just
charts
thought like
like we will be made fun of for ignoring Geo.
if
It's noble to acknowledge you. It's not a bad thing. Okay,
It was nice,
don't let
okay?
anybody tell you otherwise.
Like someone mentioned P6 was Geo and OMCA. So like I was looking forward to it. Like after looking at the statement, I'm not looking forward to it. Like what?
p1 square minus
It would be weird to see what um how this would look if it were the other way. Like if we had f of a plus b is f of a plus f of b, and we were given that at least two of f of a, f of b, and f
ah
of a to b are equal.
that sounds pretty cool. Right. Yes. So that works. What is p3 by the way?
Uh, Sequence NT.
Ah,
One of
Looks
P2 and
interesting.
P3 should have been a nice combo instead of this.
This live soul will be filled with Abhay telling us about the lack of combo.
This is bad. Okay, this is a bad thing.
Yeah, it's bad.
not enough combo.
Not even close.
A1 is a perfect square. An is the smallest positive integer. What? Okay.
Wait, what? even and for any integer,
I mean, you have to, of course, start by writing down terms.
Yes. Okay, for 16, it starts with 16, 4, 8.
A1 is 16 you took, right?
Hmm?
You took
Yeah,
A1 equal to 16. Okay.
what? Okay.
16, 4.
it was just constant then, is it? 16, 4, 8, 8, 8, 8. I think.
Okay. And what were the values it's taking? It's going 16.
36, 6400.
What? 6400?
I think so.
That sounds
Wait, what's
wrong.
happening here?
Oh, you mean to separate. Sorry. Fine.
What's separate?
Like this.
Yeah, yeah.
I thought you
Not
meant like
6400.
6400.
Yeah,
I was
no,
like,
that's a bit too much.
yeah, exactly.
Uh,
I feel we should again let this huge value be bi and consider bi minus 1.
That makes sense. We want to show that it's eventually an AP
Yes.
or something.
No, I don't think it's an
Okay,
AP.
let's see what BI plus 1 minus BI is.
It's like a1 plus dot 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 plus ai.
I see. Yeah,
that looks
eventually
nice,
AP,
but
like increasing
what?
with equal difference. Oh, go on.
Nothing. Yeah, I was just. P1 is a.
Plus AI. It wasn't AI plus 1.
Yes.
But yeah.
Oh wait, I haven't checked comments. Let's see what people are saying. Hmm. Sex is supposedly challenging. Okay, I don't know.
Hmm.
Okay, bi plus 1 is this.
Okay. And what do we have to show? That it's eventually an okay. Eventually an AP sounds kind of weird to be honest.
Eventually a quadratic.
Hmm?
Eventually a quadratic.
Hmm.
Because like second differences have to become constant.
Yeah.
Oh,
It's
okay.
like we
But
want
So
BI to
they're
eventually mimic
squares,
some
right?
quadratic.
So it's
Oh, it should be a perfect quadratic. So I see. Yeah.
this is nice, I feel.
Hmm.
hmm.
Like at okay, I'll also define ci is equal to this whole sum. Let ci is equal to a1 plus a2 plus ai.
Hmm.
Note bi is actually just c1 plus c2 plus ci.
Hmm.
Oh, yes. That sounds nice.
Hmm. And
Okay.
okay, so
Sean.
let's ignore it in terms of a1. Let's actually rephrase the whole problem in ci's. That's just nice, right? Like c1 is arbitrary, c2 greater than c1
Again,
is smallest such that c1 plus
it,
c2 is a square.
C1 has to be a perfect square. I mean, okay.
Yeah, c1 is a perfect square. c2 is the smallest thing bigger than c1 such that c1 plus c2 is a perfect square. Then c3 is the smallest thing bigger than c2 such that c1 plus c2 plus c3 is a perfect square.
wait, is that it?
What?
Oh, but the CI have to be strictly increasing. That is only
Yes.
other condition.
Wait, what does it mean that C3 is the smallest number such that C1 plus C2 plus C3 is a perfect square?
Like similar to how it says in the problem that an is the smallest positive integer. So
Right. Okay, wait. I just realized that I did not understand what that said. Let me read that again. Ah, okay. Never mind. Okay, yeah, this is much nicer. Wait, will this be two?
C2 is greater than C1.
No, will C1 plus C2 always be the smallest positive integer such that C1 plus C2 is a
Yes,
perfect
C1
square?
plus C2 is equal to B2. So
No, right, but is it possible for.
C2 is greater than C1. That's
yeah,
the
that's
condition we need
yeah,
to
it has to be
put.
strictly increasing.
No, what I mean is that,
So,
like in the
okay,
case in our problem condition, they have given that n a1 plus whatever we need, like an is like the small, like, okay, wait, let me try and explain what it. Okay, so an is like the smallest positive integer such that n a1 plus n minus 1 a2 plus that plus something is a perfect square, right? Is it possible for c1 plus c2 to be like a perfect square that's smaller than that?
C2 is greater than C1.
Yeah.
Then no.
No, like, could there be a perfect square between c1 and c1 plus c2?
No, I think it's literally identical with this condition.
Is it? Okay. uh,
Do you want to try bigger number to start with?
Yeah, sure. Let's do it in terms of C1 though.
Yeah, yeah.
Okay, C1 is equal to 100.
Where is yes, 100 smaller.
Wait,
I
did you
don't
say smaller or
I don't know
bigger?
what is it squares. Hmm.
Hmm?
I don't know. So 125 next.
C3 is equal to from
Also
225.
assume C1 square free, but not relevant. Oh,
Sure.
I mean root C1 square free.
Right.
Or
Okay, let's start with C1 equal to 81 then.
no, no, never mind. I'm just crazy.
No, no, what you said is. Oh, okay, never
No,
mind.
that's not true.
Yes.
196 is a square.
169.
Okay,
Never mind.
100,
Wait,
120.
which one are we going with?
Okay, 100, 125.
uh
So next square bigger than 225.
Next square that is
Sorry, bigger than 225 plus 125.
what's 20, 22, 23 square?
I think 19 square.
No,
361.
no, wait, it has to be bigger than 400.
Why?
Why?
Wait, what?
It has
Oh
to be
yeah, never
bigger than
mind.
Yeah,
225 plus
125,
120.
okay.
Yeah.
I was
so
trying to make it bigger than C1 plus
61
C2.
minus
Ah,
125.
361 minus 225.
136.
136. Okay.
130. 136.
What is this? 325 4.
Uh,
No, I'll also just write the partial sums below and hope that people. Okay, I'll just stop. People say they can't read anything.
no, they can read that part, I guess.
No, no, my handwriting, I mean.
Oh, it's fine.
No, that's quite fine.
Okay, what is 361 plus 136? 497.
529.
Right.
529?
Yeah, 529.
Yeah.
How to subtract?
Wait, so another way of even ignoring the bn. So bn is smallest square with uh, bn plus bn minus 2 greater than 2bn minus 1.
Oh,
Why is this true?
Because just think it in terms of Ci. Like Cn greater than Cn minus 1 is just saying that Bn minus Bn minus 1 greater than Bn minus 1 minus Bn minus 2. Also, is it non-negative or positive? It's non-negative, time to change
No,
that.
positive integer.
Oh, okay, cool.
Okay.
Okay, actually, let's ignore the Bn also, honestly.
Ignore
Yeah.
the pen. What are you dealing with?
Sorry, ignore the
L-
Cn and just
Ah,
deal with
Wait,
the
why?
Bn.
Wait, I thought CN looks nicer. I don't know.
yes. And
Okay,
okay, no, like Bn lets you deal with only this in previous term.
yeah.
Then you have to deal with previous sums.
Mm. Okay.
In fact, I think dealing with Bn, you can say that root Bn grows smaller than linear.
Root Bn has to grow exactly linear, no? Eventually.
Yeah, eventually, but it's always at most some linear.
Oh, yes, okay, by induction.
Just by analyzing Bn, Bn minus 1, and Bn minus 2. Okay, I'll let Dn be root Bn. Right.
Hmm.
So the condition is that dn square plus dn minus 2 square greater than 2 dn minus 1 square. Yeah,
2d and dn minus 2.
yeah, I'm claiming that dn minus dn minus 1 less than equal to dn, sorry, yeah, less than equal to dn minus 1 minus dn minus 2, or, and to do this, I'll say if it's greater than, just take dn equal to this. If it is greater than, just instead take dn equal to 2 dn minus 1 minus dn minus 2. And I'm betting if you put this in the square thing, it will satisfy the criteria. Let's just check that.
Also, you may want to write the 2d and dn minus 2 when you
Uh,
square.
Mm.
when I square?
Like dn square plus dn minus 2 square plus 2d and dn minus 2.
Sorry, I didn't quite get.
Like here.
Yeah, it will satisfy the square condition.
No, like 2dn.
Oh, why is that a plus 2d?
You square it.
Also, sorry, just 1 second. I'll be back.
Oh, I'm crazy.
Wait, what?
No, no,
Oh, wait,
no.
no, that's just substituting.
Yeah, it's correct as written.
Yeah. Oh, by the way, hi, Ethel. I never said hi.
Oh, yeah.
Okay, yeah, I'm back. Sorry.
Okay, yeah, I was just crazy.
Okay, which part was confusing though? Because if you got confused, probably most people watching it. Are there people still watching?
Yes, yes.
Oh, okay. Cool.
They're like 20-ish people, which is like pretty good, I think.
18, yeah.
Yeah, and we just need to verify if this checks the square condition, which I will calculate. This
Hmm.
square
Or
is,
you
I
can
think
do
it's
that.
AMGM
Okay, so
plus dn minus 2 square minus 4dn minus 1 dn minus 2.
2b square. Yes, it is MGM. We are done. No,
Mhm.
sorry.
Yeah, I mean, if it satisfies this, we are done.
It satisfies that.
Okay, then.
Wait, you got at most linear.
Yeah, so like dn minus 1 keeps on decreasing. So it's
Yes.
eventually constant.
Okay. Yeah,
Is that it?
yeah.
Okay.
Like, are you sure there is no flaw? Like, I'm just looking for an excuse to not do B6.
But actually, let's go through this. I feel like we did a lot of unnecessary stuff. So let's just rewrite this with what we actually need. So, of course, BI we need to define as the stuff.
Ooh, we can just define DN direct. Okay, sure.
Okay, that'll probably just make it harder though.
Yeah, yeah.
AN and DI, sorry, this is BN, and DN is equal to root BN. And we have that BN plus 2 plus BN minus 2BN plus 1. This is just equal to, what is this equal to? AN, no wait, do we ever care about this value?
Mhm.
I'm getting confused, sorry.
You can,
Like, this is supposed to be greater than equal to 0 for some reason.
yeah.
What is supposed to be written?
That's
Yes,
because
yes.
EN
This
minus
is
BN
just
minus.
this is just
Yeah.
equal to AN plus 2. So in other words, BN plus 2 is smallest square greater than 2BN plus 1 minus BN. Because
Yes.
AN plus 2 was the smallest thing you need to add to this to make a perfect square.
Hmm.
Like this
Uh,
part is just le- last part before you add AN plus 2. So BN plus 2 is the smallest square greater than this. And then actually I won't even define BN. Sorry, actually I will define DN. So then claim is that dn minus dn plus 1 minus dn is non-increasing, and you can just do that. Otherwise you'd get, if it actually increases, just take it to be non-increasing under this condition that this must be greater than 0 is not violated.
hmm.
So this works. Oh, okay, we get dn plus 1 minus dn is constant. I'm pretty sure that's equivalent to literally what the problem asks. What does the
Yeah,
problem
yeah.
ask?
It
An
means
equal to
that
a.
BI is just a fixed quadratic and you can take difference and show.
Yeah. Uh,
Right. So we are done.
Yeah.
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 Okay,
Okay.
I'm gonna take another opportunity to complain that there's only one combo on this paper, which is like insane. How sad must the people be? They literally went through day one without looking at a combo. That's like really sad.
They had a great combo though. Like EGMO always has a great combo. Like last year they didn't, but like I think most years.
Okay.
Like in the past, EGMO's always had like great problems. I think. Like
Right.
2016, 2017, 2018, 2019. I don't remember.
Okay, I don't remember any year. How do you remember those?
No, like half the great combos after I've done are from like,
Really?
yeah, like in the past I thought EGMO had lots. Let's just see. Like,
I'm
oh, the
not
collection
that
is
much of
already
a
made. I
fan
see.
of P3, honestly.
Hmm?
I'm not that much of a fan of P3.
Exactly. There should have been a combo.
I agree. Or at least like an NT where Prettier?
This is not anti-real, right? Like this is algebra.
Oh, a prettier algebra then.
When is algebra pretty?
P2 was pretty, or is that NT?
That's anti.
Yeah.
Because P4 algebra?
Yes. Or I don't know what that is. Yeah, algebra is what it is.
Okay. Also,
I
I just
feel that they're
realized
like,
I did something very silly while streaming.
What
I
happened?
kept Miro in, no, not that big of an issue, but I kept Miro in the same window as other YouTube tabs. So whenever I switch to the YouTube live stream or the meets, it'll switch in the,
Oh,
oh, oh, you can just like remove it now, right? I mean,
yeah,
you can just like, change that now. You can just,
I can do it now, but I
it's
mean,
fine.
it's fine. Like, okay, I also feel that there are like three-ish questions which have like sort of a sequence in it, if that makes
oh,
sense.
also removing it now didn't work. It's now only showing the YouTube live stream, so I'll put
Is it?
it back.
Okay.
Oh, I'm a minute behind.
What?
I was confused why there was like a minute lag. Like I was
There's
just a minute
always
behind
some
in my phone.
20-second lag though.
Yeah.
Wait, I think. Wait, is it that much?
No, that's not. I just missed.
Some large amount.
Yeah.
Okay, I'll put a P6, I guess.
You will hurt people's eyes.
Dude,
This is not nice. I don't like this statement. What is the statement? Like, Abhay will do combo propaganda. I will do anti P6.
why are you guys
I'll
so
support
biased?
you. Like, like we are not against each other. We should work together, team.
Yeah, like replace P6 with combo. I won't mind.
I wouldn't mind at all.
I think this is supposed to be an EGMO Livesolve.
This is the
Okay.
move.
We will attempt problems too.
Okay, I didn't read the rest of the question, but does the last statement like are they essentially saying assume X Y Z W or concyclic?
No,
OX,
no,
Y,
it's
Z.
stronger. Aren't XYZ always concyclic?
Okay, wait.
Probably. That would
They
make
are,
sense.
right?
Yeah.
ABCD cyclic. You have to use that.
ABCD internal language.
Wait, let's see. Yeah, okay, it is just cyclic always. So you're saying if O lies on it, then
So does P.
okay.
Um,
Oh wait, did somebody
what
draw the
is
type?
P? AC and BD meet at P.
Like,
P and O are isogonal conjugates, right? No, I'm completely grazing. Sorry.
okay. Oh, are you saying like in the special case that isogonal conjugates or something?
No, no.
Ah, that would be very nice though.
It's just not true
Because
though.
like you have angle bisectors.
Huh. I just assumed the altitudes are perpendicular. Sorry, I just assumed AC and BD are perpendicular somehow.
Nice.
Okay, so O lies on circle implies P lies on circle. It's not that bad.
Okay.
I'll draw a large circle. Can we call it a semicircle because it partly looks like a circle? Okay, perfect.
Pranjal, by the way, that semicircle joke, oh, if that was supposed to be a joke, it was not a good joke.
Sorry.
What semicircle joke?
See, people don't even realize that it's a joke. That's a bad joke.
How do people not realize it's a
What
joke?
joke? What did you say?
He
Okay.
said this looks partially like a circle, so let's call it a semicircle.
Okay.
And the joke was also that one side actually looked like a line.
Okay,
See,
that's not a good joke.
it's layered.
Pranjit, there have been way worse circles. This is a good circle. Like that's a good circle. You could use Miro to draw circles, right?
You can.
That's like a shapes button.
Wait, where?
I mean, that's wait, what? That's it's like fifth. Like you have the pointed button, and then you have the
Pointed
sun,
button.
Oh, and maybe
and then you
already
have the
drew it, so I guess no point now.
okay.
Does this absolutely have an in center? Okay, sad. Okay, fine. Let's
Like
just use
it's
the
not
shapes
supposed to have
button.
a center. All points defined are distinct.
Uh, this is
Wait,
not a
did it?
circle.
It's not.
No, it's an
It's
oval.
fine. We will deal with inaccurate diagram. Don't delete. Oh, that's a square. I see. Okay,
Don't
let's
take a
take
square with one.
to inaccurate.
Ah.
Maybe pressing shift creates a perfect circle. No, shift creates nothing. Ouch.
Oh, use the background squares to draw.
I could do that if I was an artist, but I'm not.
You have graphic tablet. You should draw nicely.
I got graphic tablet for free. That's the only reason I have it.
Wait, there should be a better way to draw a circle.
Oh my god. I can draw a better circle on paper. Like, graphic tablet is still much worse than paper. Tell me if either of you
Wait.
guys have a nice circle.
Oh wait, I think I. What am I doing? Okay, shit. I did something. I don't know. I think I added a flowchart.
You did well.
He
Wait, what did
added.
I do?
I don't know what this is.
Okay, I think I added a flowchart.
We attempting a geometry question and algorithm.
Flowchart. Yeah, I've had this combo. He'll like draw this flowchart of algorithm.
That was a circle though. We could have used that circle.
Okay, this is circle.
Let's just use this. Let's pretend it's a circle. Let's call it the fool's circle.
It was nice before. That one was nice. It was better than this.
I can control Z enough times and get it back.
Something is happening to my Miro.
It got exasperated at our circles and gained self-sentience.
Yeah, no, it's giving me suggestions.
Like
Sounds like
anything
it did gain
than what you do.
self-sentience.
It's literally saying things like snap on grid or something like snap to grid. What the quick diagram creation? It's literally giving me tips.
It knows you're desperate.
We will live with this. Oh, this is actually not bad.
Looks hard.
Like, we are creating a biggish quadrilateral, which is kind of what I wanted.
Sunana says it was an actually nice joke. It's not a good joke.
Thank you, Sanana.
It's not a good joke. No, I don't have some standards. Come on.
See, like when you listen to my jokes, like this is good.
No, Atul, like if you go below that, they're not jokes at all. Like,
Why does it start with X and not W? Not that it matters. I'm just supposed to draw AC and BT now.
We must use some variation of fact 5 because angle bisector equal things. Wait, this is an impressive diagram.
It's
Is
not
that
that
a
bad.
joke now?
No, no, actually, like it looks accurate.
Through
If X, Y, Z, O are concyclic, then even P lies on the circle.
Oh, also it's if and only if.
Right, okay.
Like showing X, Y, Z, W cyclic is in ninth grade NCRT. I remember.
Okay.
it is.
I think so.
NCRT is hard, so I'll believe it.
When was Geo? Honestly, like in ninth grade, Geo was hard.
Okay, Geo is like the easiest subject, but calculus is like actually hard.
Ah, see, we
It
haven't
is.
tried calculus yet.
I messed up my
Practically, we have to do.
cat differentiation is okay, but like I messed up my UT2 integration. Uh,
Oh, don't tell me about it. Even I, like, there was a 4 marker and I had no clue how to do.
I
Sir, I'm sure you have scored 14 IOQM.
wait by messed up. I mean I got 26 out of 40.
Oh, I still beat you. I think I got around 30 out of 40.
Yeah, that's like a good score.
Hmm. Okay, I got 29, but yeah. Wait, I'm actually not sure. Was it 29, 30, or 31?
What happened to the 13?
Let's not talk about that. That's not a math mistake as such, right?
Okay.
Okay, my Miro has officially crashed.
Oh,
It's
also,
literally giving me tips and it's loading and it's giving me a new tip every time. And then I don't know what it's doing. It's quick diagram creation this time. Okay.
it has gained sentience. Is the circumcenter of XYZW nice?
Circumcenter is what?
XYZW.
Is?
Is it nice?
Oh, is it nice?
Like, is it the midpoint of OP?
Like that would finish.
Wait,
But actually,
no, just taking a guess.
That would be nice if that were true.
Hmm.
That would actually be kind of nice.
that would be very nice that it's not known. Because, like, why did the people who made NCRT know this?
Wait, I mean, if it's known, it's very hard, right?
It's V6. And
Okay, I
also, I see
deleted
no way to
my.
know it.
Like, it won't be an NCRT even if it was true. That's like
Yeah, it was
a
joking.
bad
But
source. Oh,
obviously,
okay, okay,
NCRT containing EGMO 6. No.
okay. I think
To be honest, though,
NCRT did have a harder version of some IMO problem though. So
Huh?
yeah, like IMO 2019 5.
No.
I think
I
there was
don't
some
believe you.
recurrence harder than that in
No.
NCRT.
Okay,
No,
right.
I don't believe you.
I've seen
But if
it.
you think about it, though, like
Like you have to write down the good recurrence, sure, but that's not the part. Many people got stuck after that part.
Oh, writing
the
recurrences.
tough part.
Like, combo is harder than algebra. Oh, no, algebra is harder. I sympathize with that. Okay, perhaps we should start the problem.
Yeah, I am think. Oh, did all our viewers go away, by the way?
Oh, no, there's still
No,
Only
18.
18
only?
people.
Oh, okay. Wow, I'm impressed. How to do this?
If it's true, it can't be hard to bash. Like, we will not, obviously, but cannot
No,
be
it's
hard.
probably not true. It might be an interesting claim to make, though, even then.
I mean, if we draw like a really, really accurate diagram, which we won't be able to, we can
How
probably.
do you assume we're making an accurate diagram?
Like, it's not true, probably, but it's a good starting point to try and show this, maybe. Oh, also XYZW cyclic in general.
No,
Hmm?
No, that's fine,
no,
right?
no, not that.
Oh, what happened?
Uh, Look at chat.
Okay.
Okay, please don't spoil in the
Yeah.
future.
Wait, Axel, you should say look at chat. Come on.
I mean, it's already spoiled. Our claim is true, apparently.
Okay.
I don't believe it. How?
It's reasonable.
No, but valid point of view.
It's it's not unreasonable, but it is surprising.
Yeah. Okay, thank God. Not always. Not always.
Why are you
It's not true.
looking at chat?
Like in case people say stuff.
Okay, fair enough.
Uh,
Yeah,
okay.
I'm
I
happy
finally reinstalled Miro. Okay.
because
Is Miro back for you?
Wait, let me try to write stuff and see if those horrible tips come back. Oh yeah,
Oh,
it's
it's
working.
working.
Yeah.
What is this angle?
what is Q? Circumcenter? Also, is
Q
that
is
angle
circumference.
nice?
Wait, also this angle is nice, right?
Yeah, all the four angles are nice. Yeah.
90 minus a by 2 minus b by 2.
Really? Oh, okay.
180 minus.
Directed.
Yeah,
Okay,
and
1 second. I'll be back.
yeah, sure.
Uh, Give me a minute. I need to sneeze.
Sure.
Okay, yeah. I sneezed.
Okay.
Um, it feels kind of empty. Like we don't have that much to proceed with. I don't know.
Yeah, I feel like we should just write down stuff. YXW is this and YZW is this. In general.
I'm also kind of angry with the question statement. Like if XYZW is um like it's obvious that it's, I don't know, that it's cyclic, right? I mean, like the question statement is just like, I don't know, artificial difficulty.
No, like how else should they
Actually
save it?
saying that
If X,
that
O, Y, Z
speed
is
through
concyclic.
P if and only if it goes through Q. Uh,
Oh
oh,
yeah, that makes sense. Yeah. Okay, an alternative framing might be even more. My tongue
is
Yeah.
twisted.
being told the solution in DM. I'll just close Discord in case someone does that.
So WQY is something like A plus B.
Hmm?
WQY is something like A
D
plus.
plus, okay. D plus A plus B something. I'll just look at your diagram.
This
And like XQZ is probably C plus D, but 360 minus. Oh, that's also A plus B.
Uh, Guys, don't spoil in the chat. I'm gonna look away now, but
What are these?
I don't know. It just somebody spoiling, but
No, someone just said angle A plus B plus C plus D is what 360.
right. That's true in general.
No, with directed angle because we can't use it.
Okay.
In a contest, would you hand wave config issues and hope no minus one?
There's never a minus one for config issues.
Really?
Pretty much.
Like if you ignore directed angles.
Yeah. I have never written directed angles for any geo in my life.
Okay, nice.
In contest. Outside contest, I think a
Minus one
couple
on
of
a
times I
GM.
have.
Oh, you didn't in 2019.
Can we? No, never mind. How do you do this?
do we have to? Maybe we make some like weird construction. I don't know.
Okay, I'll just intersect the angle bisectors with the opposite circles. Yeah, this is for sure the hardest.
Yeah.
Okay, so-
Are you regretting extending those lines now?
yes, there are
They
many
might be
things
useful.
I regret in life. This is one of them now. Oh my god.
It's going through A. Okay, orange color.
Wait. This line, these two lines can't intersect at 2 points. It has to be on this side.
What's happening?
We are attempting
We
to
drew the
actually
midpoint of
like
arcs.
we drew two lines that intersected twice.
We did many things. Oh, yes, these are very good lines.
They are.
They're just the midpoints of arcs of BD and AC.
Yes, but
Yeah, so they have to be good. Like they pass through O.
oh,
Oh,
okay, that was a funny reaction. Like oh, because it passes through. O. But oh, okay, that is nice. Pascal, like something has to be there. Like uh, M. What is the name?
Oh,
M.
yes. Pascal
M-
is very nice.
Yeah, because that intersection is O.
Yes.
And we should get something.
NaCyX and
Let's just write down what we're doing Pascal on.
are you writing?
Yeah, MAC, NAC. Make your choice. NAC is for B.
Uh,
Oh, you're doing it that way. Interesting. I was
Like I just
thinking
want to
do
use
it
both.
on. Okay, right.
MACB.
Oh, is there a point for showing that XYZ? No, exactly. I see. Because apparently lots of ones.
Okay. Maybe I did more and got one. Maybe
Hmm.
this one. Okay, I don't know. At IMO, at least P36 have like the easiest versions. Like it's easier to get one on P6 than P1.
Makes sense.
MAC. Okay, the only slightly bad one is BMD intersection.
Yeah, I just want to use another Pascal that uses those and something else.
Okay,
Okay, wait. After NBD, what do we want? NACB and NBDA. This gives O, X, and random point BM.
BMT intersection AMAC.
Uh,
BMT intersection AMAC. Ah, what is that?
okay. That point is not that nice.
Yeah, I just want to get rid of it with Pascal by using it again. But yeah, MBD goes with what? C, MAC with D. So this point,
There's
MB.
like 27 people watching now.
See, everyone wants to watch his diet Geo. BD. Okay, Z and Q. Not Q, I mean P. This seems nice in a way.
Oh, sure.
Lines OX, PZ, and BMD cap AMC are same. Like we have these two triples of collinear points.
Wait, are you writing?
Uh, yes, just below,
Wait, where?
like to the right. Does it not show?
Ah, okay. PZ did. Okay.
Okay. PZ and OX are meeting there.
Yeah.
Please tell me WY is meeting there.
Oh, interesting. Like we should get some other similar results. Okay, I will attempt to use Pascal again. Let's see. We want W and what is that point? W. Right.
Um,
Okay, no. Not a direct Pascal for that.
Can we do Pascal on two lines somehow? Like B, X, Y is one line.
Papas,
Yeah,
not Pascal.
same thing. Like,
Okay.
come on. Like YW, B
Why
and MBD, right?
B and MBD? Huh?
And it's supposed to be okay. It has to be line MBDY. So the last point is C or Z. Suppose the last point is Z.
Okay.
Wait, sorry, I'm forgetting the statement of.
Oh, statement is
No, no.
this.
As in, I remember it. I'm just not naming good points at all.
Ah, we have an hour left for this thing.
It's fine if we can't do it. We never promised to.
I mean, how would you like to say that we solved 1, 2, 3, 4, 5 quickly and like did not do P6?
Geometry is hard, okay.
The Shravan combo.
P5 was combo already.
So
Should have been more
You couldn't do
combos.
two combo. Like, you have to at least disguise the combo. You
Excuses.
can't keep plain combo.
I
Those
don't
are
mind
just
it not be
excuses.
Geo.
Okay.
Why is he? Hmm.
It has to be a Pascal though. Like, we literally don't have any other approach almost.
Yeah, but how do you deal with?
So B and MBD and B and Y is good. So I'll put like this.
What are you using Pascal on?
Two
You
lines.
didn't care?
Ah, okay.
Okay, so what's the line through Y and MBD? The last point is probably Z.
C, Z.
Okay, both. I'll try Z first. And it should be BWP, right?
Hmm?
Also, how YB MBD? Do you
Um,
mean YC MBD?
no, like Y as in from the Y from the line MBDC.
Ah,
Wait, is Pascal silly when one of those points is the intersection point?
probably.
Oh,
Also, how does Pascal on two lines work?
It's the same thing. Two lines from a conic.
Oh, two lines is a conic?
I think so.
Oh,
Like,
That's a duality, I think. You can just write down the same thing and like write down 6 points.
okay, two lines is the limiting case of conic, I guess. Like, just take a hyperbola, which is like very close to two lines.
Ah, yeah, yeah, right, right.
I don't know how you do it formally, but mm, okay, suppose in some order I want B, X, and AC, and MBDZC.
also, this looks interesting, no? This extend. Suppose
Okay,
variable is not used. K.
right.
Z is excenter of KCD.
Ah,
So, like, we have this.
Hmm.
wait, is
And
that line through P?
oh, is it? It was intended to go through Z.
Yeah,
But
yeah, yeah. It should go through Z.
But it goes perfectly
Okay,
through
can
P.
I redraw
I
this?
mean, this is a bad diagram. You cannot blame me.
Fair.
It was like perfectly going through P.
I mean,
Yeah. Doesn't look much more believable, but let's leave it at that.
yeah, this is sad. This is sad. I'm just going to force these lines to intersect. Okay, like, for no, that's I erase this stuff. Yeah.
Wait, wait, wait. Can I force them to intersect? I think they'll intersect at the top.
Oh, then setting on top or bottom.
I think like this.
Okay, extend it whatever.
Yeah.
Looks perfect. That's a work of art.
This point is KL.
You have to make them tilt gradually so it's believable. Yeah.
Believable to whom?
Our viewers don't.
Yes, that's pretty.
Yeah.
Uh,
Hey guys, these are straight
this
lines.
no,
Yeah.
wait,
Wait, wait, wait.
okay.
I'll draw it. Wait, how did the blue line go?
Yes, Abhay, that's a suggestion to make quote log in OMC.
Yeah, we should do that. First code. This should have been. Okay, I don't mind, but like that should be like a law or something. We should have more combo in Olympiads. No, we should start like a movement. Like you know how, like I
Like,
don't know.
do you realize there was a period when people were like, stop putting three combo in contest?
Wait, what?
Like,
After 2020, I know,
IMO
I think.
2014, IMO 2020.
Oh,
And that was like a quote by Evan that says, contest will eventually be all combo.
that's a good thing.
Okay.
I mean, your tone suggests it's not, but it's a good thing. The world will be better off for
The
it.
world will be better. Okay. P and
OP is
O.
perpendicular to LK.
See, I was right. L should be
Okay,
in the
fine,
bottom.
fine, fine,
You was correct.
fine. You will have your wish granted.
Yes.
Wait, what?
No, like they're supposed to intersect at the bottom.
OP is perpendicular to LK, so it's definitely.
Okay, we will attempt to draw OP. No, that's not OP. And these. Uh,
Oh my god.
come on. Okay, a bit more believable.
And
I'll
don't
draw
bother
this.
making it exactly perpendicular to OP since that's the fact no one will catch on with. Yeah.
Yeah, you can bend like CD how much ever you want. Smaller lines can be like bent easily.
Yeah.
Yeah. Nice.
Yes, this is our diagram. L.
That should we should start like laws of drawing geometry, and one of the laws is, you know,
Okay, OP are there. I'm just adding my L because no, not yellow. Light blue. Purple taken. No. Oh, this is perfectly perpendicular. I may have bent OP, but okay.
That's the
that's
middle
okay.
point, right? Okay.
Yeah.
So L is concyclic with a bunch of stuff.
Yes, we must make L invert. No, I'm joking.
Is
Mickle
XZ
invert looks
intersection
interesting.
Hmm?
hmm?
Is
Is
Mm,
XZ intersection YW important?
ah, we will
should be.
add that point to be. Except Q is stuck in the middle. Let's zoom in and delete it.
Let me draw Q.
Q.
Okay.
And what is this point?
Oh wait, I did that too.
No, I'll delete my Q.
I
No, don't
deleted.
delete yes.
Okay, wait.
This is
Okay,
R.
Yeah. Perfect.
Okay.
beautiful.
Hmm. Mickle invert, what happens?
Why?
Like, is stuff decent somehow?
Like it swaps for 2P and BDAC.
Yes. What happens to the red lines?
Just um,
Hmm?
Hmm.
we have given pictures here.
Do midpoints of arcs swap? No, right?
Work with what?
Do midpoints of arcs swap when you Mickle invert? No, they can't. Never mind.
Wait. The do X and Z swap in Michelin what?
Hmm?
Do X and Z swap?
Interesting question.
Oh, that would finish.
How?
Like invert.
Oh,
Yeah,
yes, yes, yes,
ZW
yes, yes,
stays by itself, OP swap.
yes.
Okay, wait, I'm convinced this must happen.
Okay, what does ZX go to? K goes to L.
Where did the angle bisectors even go?
Hmm. Is something concyclic with ZX?
Oh,
Wait, is CXZB concyclic? No, right?
ZB. No way. Uh, Hopefully not, otherwise I will feel very silly.
CX said no. Hmm.
I almost want to bet they are concyclic.
Okay, let's just check the angle. Um,
KZC is KDC is KBA. Okay, then,
Wait, how are you dealing with the angle?
sorry, C is eccentric, right? They
C is
are
ex-
concyclic.
what?
Yes,
Yeah,
I'm
What?
pretty sure they're concyclic now.
really?
Yes.
What is the? Oh,
CZXB, right? Uh,
oh,
Hmm.
is your proof like power of point from K?
Oh, I just angle changed, but
Oh, how? What?
BXZ is BXK is 90 plus A by 2.
Wait, DXZ?
BXZ
Huh?
is BXK
okay,
is
yeah.
90 plus A by 2 in center. So 90 plus A by 2.
Hmm.
And BCZ is just C by 2.
Oh,
And their sum is 180 degrees.
what?
So
That is.
BXCZ is concyclic.
Oh,
Okay.
wait, does this imply inverse somehow?
Okay, so BXCZ will go to the circle AD something something.
Hmm.
Hmm.
And we want to show it goes to ADXZ.
Someone has the same shirt as this. What? Okay.
Same shirt.
Apparently.
Oh wow. What's the circumcenter? Is it NBD? No, no, it's not. Thankfully.
If we show that OP is angle bisector of ZMX, are we happy?
OP is angle bisector of ZMX. I don't think
Uh,
that's enough.
Yeah.
is that true though?
Oh, it has to be if they're inverses.
No, I mean, is that like a fact or something? Because
No, no, I was asking if it's true.
no, I think it's true.
Oh,
I think you can prove that.
How?
I'm not sure though. No, I just remember doing the like studying that configuration 2 years ago or something. I don't know.
the days when
Okay.
you used to do Geo and not combo.
Yeah, I've pretty much given up on Geo right now.
Would the past Abhay be happy with P6 as Geo?
No,
Okay.
I was always a combo plus. Like this is not a good question. Like it should have been combo, right?
Okay, doesn't seem
But
that bad. My initial opinion of it was misplaced.
Is
but
KW
you
equal to KY? Sorry to cut you off. You were saying?
no, I mean Atul, you would agree that if this were a combo, the paper would be better.
Yeah,
Yeah, okay, that's it. Okay, good.
like I'm in support for extra combo always.
Good.
Is XYZW harmonic?
What?
Oh,
XYZW.
Oh,
And are the tangents KW and KY?
seriously?
Just taking a guess.
Okay, so KZKX is KBKC. So you're
Hmm.
claiming KW tangent to KWC, I mean BWC.
Yes.
That's true.
It's what I'm claiming. I don't know if it's true. I'm claiming KY tangent to BYC. I think that's much nicer to look at.
What's the difference?
W is for AD, Y is for BC.
Ah, okay.
So I'm claiming KYC is equal to B by 2.
Okay.
KYCS?
B by 2 is my claim.
Okay.
Could be false.
Oh wait, I've been like looking at my iPad like that, and I just realized I could just, you know, move my iPad instead of my head.
Mikkel was nice. I want AC perpendicular to BD. Are both conditions equivalent to that somehow?
Really? What?
Just a
Wait,
guess.
what?
Oh, like from the beginning you have decided AC should be.
Yes.
Okay. Sure.
Okay, do you want to just check if the problem is true for ABCD being a right triangle?
Right triangle.
Yes. D equal to C and AC is 90 degrees.
Oh, okay.
Because if so, I'm just like claiming AC equal to AC perpendicular to BD and you should prove that.
What if the inverses in general?
ZW. That's strong. I don't think that can be true.
Hmm? Oh wait, you guys are there. Okay.
Mhm. Oh, where are you? Oh, there's a new
Oh,
diagram being drawn.
no, I was
Yes.
just trying for a right angle. Triangle. Trying special cases essentially. A, B, and I'll draw the tangent. So you have the in center as X, this angle bisector intersection B angle bisector as Y. Oh, I'll just draw K. Y in center KBC and X center KAC essentially. And what's the last one? Last one is C. W is equal to C. No, Z is equal to C also. And this is W. Okay. And I'm claiming O lies on circle XYZW. That does not look true, unfortunately. Okay, never
Like
mind.
slightly off.
Slightly off.
Slightly.
Just a little bit.
Yeah. Okay, fine. AC is not perpendicular to BD. It's not true in general though. W and Y being inverses.
Oh, it's not?
I mean, won't that imply OP XYZW being concyclic? Just
No.
Hmm?
okay. Won't it imply OP YW is a circle if they're inverses?
OP?
YW is a circle.
It would.
It would,
Okay.
right?
Yeah.
Yeah, it would imply they're a circle. So OP YW is a circle, XYZW is a circle, and
Okay. Does not look.
okay, it at least implies OP XY and ZW. Sorry, OP XZ and YW
Hmm.
are concurrent by radical axis, if not all 6 points are
It
on a
is
circle.
concurrent.
Okay,
Oh,
so suppose in general they are Mikkel inverses.
I see. Yes, right. So
Yeah,
X, Y, W, and OP concur.
yeah, which is not true, probably. Like,
Are you sure?
that seems quite off, and I don't think that requires any very complicated one.
Makes sense.
So, if BXGC is a circle,
Hmm?
nothing. What if we invert at R?
Uh,
What is that? Oh, this problem is going to be hard. I can feel it.
Yeah, like I honestly don't think we'll be able to do this one in time.
We have 40 minutes.
Let's try, I guess.
uh,
Oh, R is in center of KL something.
K?
Is it?
Eh,
Oh no, never mind. R is where the angle bisectors of ALC, AKC meet.
Yeah.
hmm.
ALC, AKC. Two angle bisectors. That is interesting. Why are there only two lines through R? Shouldn't there be three lines?
What's the third line?
It's a quadrilateral, not a triangle.
I know that much, but there are
There should only be two, right?
there are three lines to through X, Y, Z, and W. What makes R special?
There are three lines to it. What
What?
do you mean?
Through X, Y, Z, and W, there are three lines, but only two lines through R.
Wait, what do you mean? Three lines?
Through X, there is
Oh,
B X Y A X W
that's
and
probably
KZW.
because we drew the. Okay.
Like we have essentially taken complete quadrilateral formed by lines A, B, B, C, C, D, and D, A, and drawn all the angle bisectors, right?
Hmm.
I
And
see.
yeah, this is strange.
Also, BXZC cyclic. This should mean something. Please mean something.
Are there any
Oh,
cross?
sorry. Like KZ into KX is KB into KC.
Yeah, is
So
Km into KL.
no, not that. K lies on the radical axis of that small circle and ABCD. So does L. So KL is perpendicular to line joining centers.
How does L lie on the radical axis?
Same. LW
Oh,
into L. So KL is perpendicular to OQ. So OQP equilinear actually.
OQP is collinear. Okay, brilliant.
So that thing has to be true. OQ equals QP.
Hmm. Like in the case of
In
the
the special
problem.
case.
Yeah.
But they're collinear in general, which is interesting.
No, yeah. OQ is always perpendicular to OQP is always collinear.
Hmm. That's pretty cool.
Also, KB into KC is equal to KM into KL.
Hmm?
KB into KC is equal to KM into KL.
How?
MCBL are concyclic, right?
MC? Oh, right. I
Yeah.
see.
So MZXL is also
MZ.
MZ?
XL is concyclic.
Oh,
Okay.
I see. That's cool. Michael invert.
Yeah, like MZXL is supposed to go to the line KZX.
Yeah.
How do we show that?
We know it goes through a line through K. I mean, wait, it is a line through K.
Right. We just want the angle to be correct, right? We probably have enough information for this.
Do we?
What's the angle MZXL makes to the line LM?
MZ.
With the line
LM.
L?
M.
Ah,
Wait, what? XZ with LM?
Oh, sorry, this is just equivalent to wanting angle bisector of X, M, Z to pass through stuff.
Ah, someone is asking how is MZ XL cycling?
Power of point from K. So BLMC is concyclic, so Kc into Kb is Km into Kl. BCZX was concyclic, so Kc into Kb is Kz into Kx. So Kz into Kx equals Km into Kl, or they're concyclic.
ADML is concentric.
Yeah. Wait. So MLXZ is concyclic, and we want ML to be the external bisector of XMZ.
Hmm.
We want XL
Yes.
equal to ZL.
Oh, so your conjecture was correct.
Yes, XL is apparently equal to ZL, and KW is somehow equal to KY. I really want to bet they're both tangent,
That would be nice.
but only in this special case.
We are moving towards unique solution. Interesting.
Okay, why is it equal? Is L the center of something interesting?
Hmm.
L is not the center of anything, right?
L no.
Okay. Oh, also apparently if you K invert, fixing the green circle,
Okay.
Y and W are fixed.
That's you're saying tangent.
Yeah, but I'm rephrasing it in terms of inversion because I actually want to invert.
Hmm. Makes
So like
sense.
earlier, if you have KBY equal to B by 2, we need to prove that KWB is 180 minus B by 2.
Hmm.
Or we want to show,
KWP is 180 minus, okay.
we need to show K, sorry, did I mess things up? I think I messed things up a bit. I think we want KCW to be 180 minus B by 2.
KC. Wait, what?
Sorry, I can't invert 1 second. So we have KBY equals B by 2. After inverting, we'll have that K by star B star is equal to B by 2. So we want KWB,
Pi star C.
KWC, KWC.
Hmm.
This is what we want. Was there a single circle with KCW in it?
K?
C
CW.
W.
KMYW is concyclic.
Okay, that might
KM,
be good.
KMCD is concyclic and KMAB are concyclic.
Okay, most don't have W though.
KMYW is concyclic.
Hmm. So KWM is like KYM, and MWC is nothing nice.
Okay, say we okay. So in KMYW, if your conjecture is true, then KW is KY. Let's just
It has to be true.
You know, there's like people, lots of background noise. I'll mute.
I think I got it.
Oh,
Like something. Like don't look at KBY. KBY is a bad angle. Look at KXY.
okay.
okay.
So KXY is equal to ZCB equals C by 2.
Yeah.
So we want KWZ equal to C by 2.
KWZ is
And KWZ is KWY minus YWZ. I think we know both these angles, right?
KWY.
what?
How do you know KWY?
Oh, we don't. KW. Oh, ouch. Oh, by tangency, we just want to show that KWY is equal to WXY
Yeah. Yeah.
or KWZ is WXZ.
Also, like, I'm curious. Can't this already feels very restrictive? So, like, suppose this circle XYZW goes to another circle. Suppose like this circle. It still has its center here on the line, somewhere here, and still has like X inverse, Y inverse, and stuff. Like, is there just a unique circle like that?
Hmm.
Okay, what properties of the inverses of XYZW exist under Miguel invert?
They don't seem that nice.
Yeah, you're right.
Like, okay, if you can tell me XMP, ZMP, then I think we know a lot.
Well, I've given up trying to show XC inverse. Like, I'll just settle for showing XYZW goes to itself.
Okay.
So, like, the center, its center lies on the same line. Also, I guess, like, if we don't solve it under 20 minutes, we'll have to end.
Yeah.
Hmm.
Because, like, at 7 we have that.
Yeah. Okay, what progress do we have so far?
Bunch of like million cyclic quadrilaterals or
I,
Right.
something.
I think OQ and P concyclic line and straight liners
Yeah,
useless.
yeah.
What license straight line?
OPQ.
Yes, that.
What if we do inversion at K followed by inversion at L, followed by inversion at M? There is some theorem about what's it called? Composition of inverses, right?
Oh, never seen it.
What does it say?
If a composition of inverses fixes some set number of points, it is identity.
If an inverse what?
Uh,
Fixes some like 5 points or something, it's identity.
Oh,
we can figure that out, right?
Yeah, like okay, what's an inversion?
What happened?
like there's background noise.
Ah, is an composition of inverses a transform of this form? For
That's a spiral sim.
this is
For a
spiral
plus c
sim.
not equal to 0.
Oh, oh, and for replace t equal to zero,
Uh, I don't remember. Like a plus d equal to 0, it's an involution.
it's probably an inversion, no? Because this is standard inversion.
Yeah, probably involution. Yeah.
No, okay, wait. By
No, no,
involution,
not an involution in that sense. As in, if you apply it twice, everything will go back. No preserving collinearities and cross ratios.
oh,
Like in general, if you repeat this twice, it's a common JE fact.
okay, okay.
It is.
Yeah, like in functional equations, it's
I'm
used, right?
supposed to be doing GE right now.
Wait, didn't you already? Anyway.
You're in MIT.
Yeah, but people are not letting me enjoy my life.
Okay, so if we compose inversions followed by reflection, the end result is going to be something of this form, where f and g are linear polynomials.
Okay. So it's
And
either a spiral sim or a inversion.
I don't think it's two somehow.
No, no, it has to be.
Wait, so the two inversions together are a spiral sim?
Okay, maybe not.
Hmm.
Maybe.
No, no, can't be.
What if you do two inversions with like the same center but different radius?
That's a spiral sim. You're
Yeah.
just expanding. But different points.
What if you do the inversion at k, then at L, then again at k, and then again at L? This is like fixes everything.
Yeah, I was thinking to K, then to L, then to the one at M.
Ah, I see. Yes, that. Can you hear like stuff?
Yeah,
Yeah.
but it's fine. Or do K, L followed by P?
Yeah, like anything on that line, like, or just even a reflection across that.
Okay, wait. So what is an inversion at K followed by an inversion at L? A is going to see A and C are swapping, B and D are swapping.
Is it equivalent to make it invert?
I guess so.
Okay, really?
Because see, X and Z are supposed to swap in Mikkel invert, and they're supposed to swap here.
Okay.
So I'm pretty sure it's the same as Mikkel
Okay,
invert.
we have reduced the problem to proving this.
No, this is not just enough. Like, okay, this I'm sure we'll be able to do. That K inversion followed by L inversion is Mikkel inversion. So that can't be true.
What if it is?
No, no.
We don't know how
Wait,
inversion.
P inversion followed by Mikkel inversion and reflection keeps ABCD constant.
Also, P is also center of OKL.
Hmm.
Okay, okay.
Yes, OK is perpendicular to PL.
Interestingly, P is also fixed in K invert plus L invert plus Mikkel invert.
Rajan doesn't get jokes.
See, like we will just develop new theory and inversions.
See, at least new theory is like combi, okay? I don't get why Abhay is not on our side.
For what?
No, no, I'm actually honestly very curious now. Is K invert plus L invert the same as Mikkel invert?
Yes.
Because look, A, B,
That
C, D are being fixed. X, Y, Z, W are supposed to, like, given the problem is to X, Y, Z, W are fixed.
is supposed to go to itself, yeah.
Yeah.
Claim
And
that it
P
fixes also.
also goes to O, whichever way you do.
Hmm.
So I'm pretty sure now K invert plus L invert is same as Mikkel invert.
Okay.
It has to be true. And also, by the way, we don't need this for the problem. For the problem, if we just somehow show that kw is equal to ky,
Hmm. But this is more interesting. Let's just do it. We have 15 minutes. Why not go crazy?
yeah, I'm saying that this is kind of relevant to the problem. Like, okay, assume that kw is ky is that tangent is true.
Hmm.
Then k invert, fine, followed
Hmm.
by L invert.
Okay.
Each time circle xyzw is fixed,
Yes.
but O ends up going to P after you do the two inversions.
Yes. Yeah, that finishes.
Yeah, so we just need to somehow show that kw is equal to ky.
Yes. Or we can do the inverses.
Yeah. I never knew K inverse plus L inverse is Mikulin. It is true. Okay, do you
Hmm.
want to just check this on GeoGebra? Like, not
No.
nothing related
No.
to the problem. Nothing
No.
related to the problem. Okay, fine.
No. This feels like you're close. Like we have to be close, right?
Yeah. KN. What happens to the line BX after you K invert? It goes to KYC, KZC.
Hmm.
Line BX goes to this circle,
Line BX.
goes to
Yes.
KZC, and
Okay.
line CZ goes to. Y can't be fixed under inversion. Oh no.
Hmm.
Y is
Why?
not fixed in under inversion right now, I think.
Oh, really?
Yeah, because line BX, Y lies on it.
Hmm.
Line BX is going to line, sorry, to circle KCZ.
Okay.
And Y lies on CZ, not KCZ.
Oh.
But if you can show it lies on circle XYZW,
Hmm.
maybe something still holds.
Hmm.
Oh, then that result might be false. K invert plus L
Isn't
not
it?
is ever decided.
This is not looking good.
Hmm. Okay, let's intersect these two circles at point U.
Hmm.
Is this like Clausen-Schmidt conjugate?
Which two? Oh,
Oh, X and Z are Clausen-Schmidt conjugates, right?
oh, are they? How?
How's Clausen-Schmidt conjugate defined? They
Take
are.
What
some
is what
once
are
this way,
clauses with conjugates?
like intersect once this way and then that way.
Oh, they're not, but they
I
have to
don't.
be.
They probably are.
That's so sad if they're not. Uh, U.
Hmm?
No, no, I'm just thinking about point U.
What is you?
I intersected B, X, K, and K, C, Z.
Oh no. Okay. Oh, 1 second. There is a fly. Okay, go away.
Then XUZ is XUK minus KUZ. Is XBK? Oh, okay, okay. This is very good.
Hmm.
I think we are done.
Huh?
Maybe.
Huh?
I'm not sure. XUZ is equal to XUK minus ZUK
Yes.
is equal to XUK
X
is
b
180
by 2 minus zuk
ZUK is Z minus C by
c by
2.
2.
Now this is equal to X by K.
X by k.
XYZ. Oh, never
Yes.
mind. Cannot.
So u
Yeah,
lies on
yeah,
this.
yeah. U lies on the circle, which is obvious
Okay.
actually. U is just the inverse of this thing.
U is inverse of y.
Hmm. U is the inverse. Okay,
Wait,
so
so this inversion fixes this circle also.
yeah, so K inversion. Oh, we were always done.
Huh?
Okay, look at circle XYZW.
Okay.
XYZWO.
Yes.
K invert.
Okay.
Where does O go to?
P.
No.
No, oh, what k invert?
Yes, K invert. Where does O go to?
No idea.
Foot from K to LO. No, I'm mixing this up. Foot from L to OK.
Okay. Yeah.
Mm.
Foot from L to OK.
Hmm.
Now L invert.
Okay.
That foot from L to OK goes to P.
It goes to P.
Yeah.
Yes.
How?
Foot from L to OK after you L invert.
Why does that follow?
Um, like the power of point. LP into L foot is LM into LK is the thing we're inverting by.
Oh, P. Oh, P. Okay. Yes. Yes.
Yeah, so the circle was fixed in both inversions, but O went to P.
Oh. Oh.
Yeah, we didn't need any of the thing we were trying to prove. That's probably not even true.
Okay. So we are done.
Yes,
We're done?
Yes. Can we put like a partying face emoji?
I have no
Yeah.
clue how to. Okay, but let's just summarize the proof because I'm worried we are not.
No, I think that works. I mean, most of the stuff that you said over the last 20 minutes went over my head.
Oh, sorry.
But I think that works.
In what spam?
Yeah, this is cool. I've never inverted twice like this. So, wait, what all did we need? BXZC cyclic.
Interesting.
This is
Krishna
just
says
angle.
Clausen Schmidt conjugates work.
Ah,
I didn't do any work at
Typical.
all.
okay, that they have to know, right?
Hmm?
Wait, also, can you ask him if K invert plus L invert is same as Mikl invert. He probably knows. Or okay, I'll ask him later.
Yeah.
So K inversion. In fact, we didn't even need that radical axis clever thing.
Oh, he has no clue.
Oh, K invert takes X, Y, Z, W.
We spent like 2 hours on this question, right?
Probably.
No, 1.5 hours, something like that.
O goes to,
Are you writing up? I see.
yeah, then L invert. Very cool though, like the final solution
Yes.
goes to P. So, um,
And that's what we could have done shorter apparently.
this is very short.
No, that's even shorter.
Oh, okay.
Invert
Okay,
invert fixes ABCD and hence fixes XYZW2.
excuse me, how?
Like apparently it's direct. Consider XYZW cap OM.
Okay,
This swap.
Y.
I don't know.
Wait, what?
Apparently there's a different solution that finishes in a line. Like after what we had.
Also,
Whatever.
now I'll check
Listen.
on GeoGebra if the two inversions are same.
Hmm.
Like, that would honestly be so cool.
Hmm.
Like, you just invert twice and you could have inverted once.
Yeah.
Why is there a sign in Google accounts thing in the Miro right at the top? Like near the question one P1 solution.
Um, I'll check for now. Don't ask me. I'll delete.
Mario, what's that?
Hmm?
Also, can you just share screen? It's like I can't see your
Yeah,
screen.
sure. Mm, right. Oh, yes. So, case 1 is invert at E with radius EA into ED, which you can also think of just drawing 8. Oops. I'm drawing. Yeah, and and claim is that you can do from H.
Lim
I
HK. Just check
HK.
HKC angle HAI.
I'll just check if the angle bisector. Yep, angle bisector is correct. And I'll check the length. Yes,
That
they're the
is
same.
cool.
Is this true when ABCD are not concyclic?
Oh, that
I'm
would be.
thinking.
I doubt.
Yeah. This is Clausen-Schmidt conjugation, by the way.
Wait, what?
How?
That's why it's true. See, from I to K, look what we did.
Oh, you
J
just.
is
Oh,
just
you did.
ADI intersection BCI because it's E inversion,
So you just got Clausen. You just wanted to show Clausen Schmidt conjugates and Mickel inverses.
which is true.
Yes. Okay.
Okay.
Yes, that's why it was ringing a bell.
Okay. Nice.
Wait, so O and P are Clausen-Schmidt conjugates,
O and P, yeah, probably.
which is okay. Okay, interesting.
Okay, nice. We did manage to finish. We cut it quite close, but we did finish.
Yeah, I think our issue was we spent too much time thinking KY is equal to KW. I don't think that's even true. Like, I'll just test it out. Angle bisector thing. Mhm. Mm, yeah, it's not true. That's why we couldn't
That's
prove it.
that's why.
Instead, we just needed to use the fact that circle was. Wait, how did he prove ONP are Gaussian?
I don't know. He said some stuff.
How's
We'll figure
exponential?
it out
Okay,
later.
yeah. It's also 7, so
Yeah.
perfect time to end the stream. Okay, so thanks everyone for coming and watching us.
Yes.
Yay. Yay.
Yeah.
Okay, then. Yeah.
Did it end?
Um,